Okay, great. And let me share my screen. Okay. I hope my screen is visible. Okay, great. So, this series that I have started is to make beginners aware about or make them learn what is Gen AI and Agentic AI, because these are the topics which are most talked about in industry. But when you have to learn Gen AI, there are some prerequisites that you need to know. And as far as I know, this is something that most of the folks don't get into. They would be just at Python or the initial machine learning. If you know these concepts, well and good. This would be a revision, just first 1 to 3 sessions, or it could be a new session also for you. So I'll keep it very simple, no maths heavy concept at this point. Wherever maths is required, definitely I will let you know, but I'll try to keep it simple so that it is easier to get through that. So today's session is about neural networks. How many of you have heard about networks or know about neural network? No one? Guys, I won't be able to see chat, so you have to speak up. Anyone knows about neural network? Okay, okay, no worries. So, this is part of deep learning, and today what we are going to see is we'll learn what are neurons, layers, activations, different that is forward feed and the backward propagation, then what are solvers. These are the crux of neural networks. First of all, what is a neural network? And where it got its name from, it behaves like a a human brain. So human brain is what it is made up of different neurons, right? It is so complicated machinery, you don't know on what you will, sometimes we even don't know, right, what we would react on in which situation. It is totally sometimes unpredictable, sometimes you know how you would react, and sometimes you even don't react, right? Or you just somebody said something, you just say leave it, you just don't respond to that. So that's how this neural network is based on. It is completely, they have tried to make a replica of human brain. Definitely human brain is lot complicated with what we are learning here today, but still these are part of deep learning. Why this is called deep learning is because it is not your traditional machine learning that you will get white box models. They are so much complicated. There's lot of math behind that, as well as the models that you get, the output that you get out of that, it would be a black box model. When I say black box model, you won't be able to justify 100% that how your input was treated to get that output. So that equation and all is really difficult to build up when you have a black box model. It's not something that it is bad. It is good. It generally works very good when you have complicated data, when your accuracy is something, or the performance of the model, the output is something that is means that is the most important thing. At that point of time, neural networks are something that we go about. So let's begin. We'll first, as I told you, a neural network, it is inspired by human brain, learns patterns from data, used for tasks like classification, prediction, and generation also. So that's where generative AI or Gen AI will come into picture, but this is the building block, so we have to learn this as well. Please let me know wherever you guys have any doubt. Okay. So moving on, what are neurons? These are the building blocks. They take input, multiply by the weights, add the bias, and passes result to an activation function. Don't worry, we will go through each one of them with an analogy so that it is easier to understand. So let's say uh, you are a judge, okay, of any competition. Now, now each judge is like a neuron that you have. You would need certain presentations, evidences to make a decision, right? Now, what are that evidences, that or that presentation? That is a input that is being given to you. Each piece of evidence or presentation will be given some importance by you, right? So, what we have over here is we have a judge of any competition or something, right? And that judge behaves like a neuron. What that neuron is getting, how you will make a judgment, you will be able to make a judgment when you have certain input. Now, what is the input that you will get? In this case, since you are making a judgment, you will get something as evidence. If I'm saying you are a judge in a courtroom, then you will need evidence. If you are a judge of a competition, you will need some presentation or something would be there, right? Now, you will give some weightage to each and every input. If you are having three different participants, you will give some weightage. Weight 1 to this one, weight 2 to this one, weight 3 to this one. And then on top of all of this, you will have some personal bias, right? You will have some personal tendency to make a decision. I might make a different decision, you might make a different decision. So that is known as the bias, and that by default comes into this model. This is not something that you are giving the bias. There is always a bias in neural network because we are trying to replicate a human brain, and human brain can't be so mechanical. It has to have its own judgment also, and that's where bias comes into picture. Finally, you will make the judgment by using this input, assigning it weight and this bias and all. So that's where I was telling you that what is the mathematical formula, or the simple, not mathematical formula, simple conceptual formula that we have. You will have the output. How this is done? This is activation. I'll come to activation in a while, don't worry. Weighted sum. Weighted sum of what? All the inputs that I have, okay, they would be multiplied to some or the other weights that I have given, plus the bias. This is how my output is generated in neural network. So we have this input coming in, okay, then we have hidden layers, then we have the output. I'll come to hidden layers in some time, and then we finally have the output over here. This is the input. Along with input, some weights would be assigned, and here comes the bias. Bias will always be there. You can't eliminate that bias. Now, what is this? This is known as input layer. This is known as hidden layer 1. This is also known as hidden layer, and this is your output layer. So we have total of 3 layers: input, hidden, and output. Hidden could be multiple, but overall we have 3 layers: input, hidden, and output layer. More the hidden networks, more complex patterns would be there. It most of the time it leads to a better decision, but it is not always the case. If a person in real time also, if a person is too complicated, thinking too much, you might not be able to justify your decision that you are having, or you might not be able to take a correct decision. So that's where being thinking too much is also problematic. So that's overthinking. Thinking less also, just taking the decision in a jiffy, that's also a problem. So that's where we have to select optimal hidden layers over here, and that is something that we will see in the hands-on. Any question, guys, till this point? Sorry, there's a background noise. I can't hear you if you are having a question. uh, Anyone has any question? I'll just check the chat. Yeah. Yeah, Khushbu, you are audible. Please go ahead. What is actually bias? Yeah, in it is see, everything that you have, that is a numerical equation, okay, that is a mathematical equation. That's how the output is generated. So you can understand that is a weight that is assigned. You won't be able to see that value, what is that weight assigned, which is means I'm not saying weight assigned to the inputs. That is irrespective of the inputs, you are having a bias introduced. Like if I'm talking about the human brain neural network, a positive person and a negative person will take the decision differently. That is their bias, that is their mindset that you are having. Similarly, neural nets also have a bias introduced. That is a small percentage. Like if you remember, you guys have seen linear regression, right? What is the equation of a linear regression? Y is equals to mx plus c. What is the c? The c is, anybody knows? It is the intercept, right? What is the intercept? Intercept is nothing. If I talk in technical terms, this is a bias just to make sure that your y value never goes to 0 if your x is also 0. So this is a constant term. Similarly, you have a bias in neural network. Hope that clarifies your question, Khushbu. Okay, great. So moving ahead, I told you about three layers: input, hidden, and output layer. So in our case of this judgment, what is input layer? Input layer is evidence and the witnesses that you have, right? That is your input layer, raw facts. What is the hidden layer? Hidden layer is the discussion that is happening. Suppose multiple judges are there, jury is there, they are making the discussion. Discussion is there. Filter is, you are filtering the results. You are refining your discussion or refining the presentation that you are having, the facts that you are having. So that is the job of hidden layer. Whereas the output layer, this is nothing but the final verdict or the final decision that you have. So that's how your output will come into picture, flowing from input to hidden layer to final output layer. If I give a simple, this was just the judge analogy. If I give a simple analogy, think of a company, okay? In your organizations, in your projects also, what happens? You will have a raw data, that is employees at the ground level will have some raw presentation. Then the middle managers, who are like the hidden layers, they transform that info that we are getting, how much revenue is generated, what is the output, and all these things into some meaningful summaries. And then finally the output layer, that is the CEO or the decision making layer, will make the final call whether this is useful or not, whether that project should go on or not, whether we should shut down that project or not. So that's what your input, hidden, and output layer does. Clear? More the hidden layers, deeper the discussion, more complex pattern can be learned with your data. Now, as I told you, activation function. What is activation function? It is nothing but the decision rules. Activation function is like your decision rules. It is your filters that you will have. Okay, decision rules. It is like the filters. Should I pass this? That's what your model, your neuron is saying. Should I pass this information or should I ignore this information after processing? So it is like the filter or the switches that you have. There are multiple kinds of activation function. The most famous are value, sigmoid, and tanh. Okay, what does value do? I'll just keep it simple as I told you guys. Okay, I'm just touching the surface. You can read more about this, but if you understand this much, this is sufficient for you to understand neural networks. You don't need to bother further about this. What extra things are there? If you are inquisitive, go ahead and read. That's very good. In case you want to get just have the knowledge of this, then this much is sufficient. Okay. What is value? Value is it, what it does is, if info is useful, okay, if it is positive, it will pass it. So if it is positive, it will pass it if it is useful. If it is not positive, it is 0 or it is negative, then it will ignore it. So it will make a decision over there. It's like a door guard that you have, the security guards that you have. Which person is good? Okay, or which person has the permit? Let me pass that person. Let me make that person enter the community or that function or something. But whereas if that person is like a threat or is not important, they will just reject that person. They will stop that person. So that's what is your that's what ReLU do. Where it is used, which is better, we will talk about that later. Sigmoid, as you guys have seen in logistic regression also, sigmoids will convert your input into yes or no. Basically, it is used where you have where you need a probability. Over there, you will use sigmoids. Whereas tanh, it makes your decision scale between -1 to +1. Uh, it's giving you positive and negative opinions. Without activations, the networks would just do boring linear mathematics like your linear regression and logistic regression, nothing else. That's why what makes neural network different, that is two things: hidden layer and activation functions. These are two main important things which work in neural nets. Any question, guys? Okay. So this is input, this is hidden layer, and this is your output layer. Now you are having the inputs. Okay. It is you have your this multiple neurons, and it is connected like this, and then finally it processes into the output, and you get one output over here. Now, what is happening? You, as I told you, you are assigning some weight to your input. That is auto assigned. Okay. And there's some bias also, which is fixed. This bias is fixed. You won't be changing it. So once one iteration, your data will flow from input to hidden to output. Okay. This is known as forward propagation. Your input came, it went to the hidden layer through activation with weights and all, it got processed. Some output you got, you will measure the output. You are not measuring, basically at the backend system is doing this thing. Each layer is transforming the raw facts into the meaningful patterns. And then what happens, it will measure over here how is the output get working, what is the error. This error is nothing but the known as loss function. It will measure how well my model performed, how wrong was I. That's what is the question that this model will ask. Okay, so if I have to give an analogy of forward propagation, it is like baking a cake. You start with the raw ingredients, then you mix and transform step by step, that is nothing but your hidden layer, and then you finally make a cake, that is your output. If I have to tell you about loss function, it is like we go for bowling, right? So it is the number of pins left, that is your performance, that is the error, that is how you have made. If no pins are left, then it was a perfect one, so that's the perfect prediction. If you have many pins left, it means you didn't bowl properly, your technique was not right, you made an error over there, so bad prediction in that case. So whatever is the error, that is what is your loss function. Now, what we will do with the loss function? How we can make, this is what happens in all the models, right? Input, some transformation, some maths happens, we get the output. What makes neural network difference? Neural network is different because it can learn from its own mistake. That is known as backward propagation. So what it will do is, once the error is known, the network works backward. It will adjust these weights. These weights would be adjusted. It would adjust these weights. Some changes would be done, some would be higher, some would be lower, and again it will move forward in the same direction. Input, hidden, and then output. Again it will measure the loss, and it will keep on doing this thing till it is able to shrink the mistake to almost zero. But again, it nothing would be perfect, it can't be 100%, it depends on your data also. So in multiple iterations, suppose in 10 iterations it said now there is no performance improvement, it will give you that as the output. So it is like you are preparing for the exam, it will take the test, it will check how much mistake it has done, then again review the weak areas, that is backward correction, and then again try the test and master that subject. That's how your backward propagation works. So this forward feed or forward propagation plus backward propagation together is known as one epoch. Okay, so this is the terminology that we use in neural network. It is epoch, complete how many iterations you want. We give epoch as 100,000, 10,000, whatever. It means those many iterations it will try to do to make the loss as low as possible. Is this clear, guys? Yes, no? Okay. In simple, this is what is your neural network. If I put all the things together, neurons are like the little judges who are making the decisions. Hidden layers, what are these? These are nothing but these are your neurons. Okay, these are the connectors, are your neurons that are processing your information. Hidden layers, it is the like a committee which is discussing these inputs and making the decision. Activation function, these are the rules which are deciding which is important, which should I pass, which should I stop, and all those things. Then forward propagation, it is the flow, that is input, hidden, and output. Loss function measures your error. Backward propagation is the correction cycle. And solver, I have not spoken about, it is the learning strategy. Now, what is solver? That is an optional um, input that you give to the model, but it is known as an optimizer, how well you would be learning. The solver decides how fast and in what way the network updates its weight. So there are three major solvers that we talk about. There are multiple, but generally we talk about these solvers. SGD, that is stochastic gradient descent. What's the it is good, but it learns slowly, step by step. Okay, so it goes step by step. Whereas you have Adam, this is the famous one. It is a smart learner, speed wise also it is good. Okay, then we have LBFGS. It is like a old school tutor, works well, but only for small problems. For larger problems or the complicated problems, you can't use LBFGS. SGD could be used, but it will take more time. So generally, we go with Adam. Okay, so different solvers you have, they will have different learning speed and the styles. It will, that's how your weights would be updated, and again your learning cycle will go ahead. So solver is by default we have activation function as ReLU and solver as Adam. Okay, are we good, guys? Any questions, any doubts? Are you understanding? Is my pace fine? Okay, okay, sure. Wherever you have question, please ask. Please feel free to ask. No question is silly. Okay, so feel free to ask. It is to everyone. Okay. Okay. Yep. Yep. Okay. So uh, to answer this, I'll question you back. So how do you decide what parameters you will consider in logistic regression or your XGBoost or anywhere? No, that is the evaluation. How would you select the hyperparameters? You will do optimization through grid search, right? Grid search or the random search. That's how. So this hidden layer is also your hyperparameter only. Generally, we start with one hidden layer just to first make a simple model and see how the output is, and then you can increase the hidden layer. Within hidden layers, also, we can increase the number of neurons. Okay, so this is a hyperparameter that we go ahead with. I'll show you in the notebook how we give those hyperparameters. Okay. Any other question, guys? Okay. Okay. It's not tough, guys. It's just if you will try to relate it to the analogy, it would be way easier for you to understand. So you can, if right now you are not comfortable with this, just listening to the first time, you can go ahead and listen to the recording also. It would be easier for you to go through that. But okay, Anisha, again to just to expand on that question, though I will show you in Collab notebook also. Uh, if we have one or two hidden layers, that neural network is known as shallow networks. It works very well on the simple problems, which are where your data is linear almost or slightly non-linear, like classifying handwritten digits. Okay, so these are very simple problems. So for this shallow networks work, if you have deep networks where you use three plus hidden network layers, your model will become complex, better at learning complex patterns like image recognition, your NLP, all this thing. But it will need more data, and it will need more compute also to complete this thing. So always rule of thumb is start with one hidden layer and then increase the layer if your model underfits. So that's what I told you. It is a hyperparameter tuning that we do. That's one thing. Second important thing is number of neurons per layer that we have. If we keep means very little number of neurons, very few neurons only, model underfits. It won't be able to capture the patterns correctly. Whereas if we have too many neurons, model might overfit also. It might memorize your training data and poor generalization can happen. So practical guidelines, again, this is just based on experience that I am telling you. Practical guidelines is start with a size similar to your input features. Like if you have 20 features, you can try with something. Generally we take in multiples of 8 or 4, that the neurons. So I can go ahead and try with 16 or 32 neurons near to your input features. Use fewer neurons in deeper layers, like if you have too many hidden layers, then you can try with 64, 32, or 16. Gradually try to compress the information. This is all fine tuning, that is hyperparameter tuning that you are doing, right? So this is how we try and test with different hidden layers and neurons. But to start with, you can start with number of features, means somewhere near to number of features. uh, Good for small data set, one to two hidden layers, and each with two times or three times of your number of input features. Medium data sets, if you have, you can try with two to three hidden layers with decreasing neurons per layer. Like if you are having three layers, first layer can have 64 neurons, second layer can have 32, third layer can have 16 neurons. Whereas if you have large or complex task, then you can start with more layers, 4 or 5 or 10 layers, and use regularization, that is dropout and batch norm, that I'm not going to talk about. It's complicated. But as of now, you understand that this is hyperparameter tuning, and these are the rule of thumb that you can start with. So there's no fixed formula. You can try grid search, random search, or AutoML to find the best architecture that is working on your data. Monitor the training versus the validation accuracy or whatever metric you are using to avoid underfitting or overfitting. Okay? Any question, guys? Okay, great. So if no questions, I'll go to Collab. Ye- I'll tell you, for hackathons, people use neural nets only for classification. Okay, because it will give you a good accuracy for a hackathon. And it doesn't matter your model is black box or what, your accuracy matters. That's where they will go. So Nowadays, until unless you want an explainable model, people go ahead blindly with neural networks. Okay? Then it is not in your course. So, yeah. So you guys can make use of this notebook for your hackathon if you want later on. Yeah, yeah, I'll share this. This is a collab notebook only. I'll give you the link. You guys can use it. Okay. So let's see this notebook. I've kept it very simple again because this is just the start. That's why I've kept it very simple. See over here, what is this? It is just one hidden layer neural net. This green one is your input layer, blue one is the hidden layer, and red one is the output. So this is just one input will go to all the hidden layers, sorry, all the neurons in the hidden layer. Similarly, second input will go to all the neurons. I'm having three neurons over here, and then this is the output layer. And finally, I get just one output. I will have an input and a weight assigned to that. I will have the bias, and this is the activation function inside this, and then I will have the output. That's what architecture I taught you. Okay, simply NumPy, Matplotlib, sklearn datasets I'm using because I'm using the available dataset, that is breast cancer dataset. So loading the breast cancer dataset, that's what I'm using. Otherwise, you guys can skip this sklearn import dataset. This is in the sklearn library. That's why I've used it. sklearn.model selection import train test split. This is something you guys already know. Matrix accuracy score, you know. This is the only new thing which you can see over here. sklearn dot neural network import MLP classifier. Now, what is MLP? MLP is multi-layer perceptron classifier, which is the other word for neural networks. I am having multiple layers. That's why it is known as multi-level perceptron classifier. Similarly, you have for regression. So it would be multi-layer perceptron MLP regressor. So you can use neural net for regressor as well as for classifier. All good? Okay. So I am importing these. It will take some time. Meanwhile, guys, some hygiene practice. Though generally we do this in Python notebooks, but this is a Jupyter notebook. Still, it is always good when you guys go into industry, when you are using some real-time problem. Whenever you are writing a notebook, your code, make sure you write this. Anybody knows what is this known as? Whosoever was in my batch, I have told them what is known as. I don't know how many of you remember it. Anyone knows what is this? This is known as doc string. Okay, this doc string, it's like a comment that you have within your notebook. This is just a hygiene parameter. Okay, not something mandatory, but a good practice. If you get used to this, it would be good for you when you get into the industry with in this field. So what is this? You can write over here as you can see. This notebook demonstrates binary classification using breast cancer dataset. How forward and backward propagation happens in sklearn's MLP classifier. So you are just giving the commentary over here, what your function or what your notebook is doing. So over here, I am loading the data. Then X and Y are there. Data will have is going to your input. Data.target is going into Y. So this all is simple. It's very simple data set with 569 rows and 30 columns, and we have two classes where we are identifying the cancer as malignant or benign. Now, as you guys know, we always split. I'm not going to do any ED or anything over here. It is just simple neural network that I am going through in this notebook. X train, X, but ideally you should do all those things. Okay, X train, X test, Y train, Y test. Train test split, X and Y, test size 0.2. Random state 42. This is the best random state. Always use 42, make it a habit. There is a lot of theory behind those things and all, but everybody agrees that 42 is the best random state to give you the output. Okay. So this also plays a role in your accuracy on and other things, though very small role, but still a slight change on in your accuracy is also a big win many a time. So make sure that you keep random state is equals to 42. Okay, now this is the function that I have written. Train and evaluate hidden layers is equals to 32 comma. So or hidden layer sizes. So how many neurons would be there in my first hidden layer? Always it would be 32. Activation function ReLU, max iteration 500. What is max iteration? Can anybody guess? What does max iteration will do? Yeah. Hmm. Yes. Exactly. So it is the maximum number of iteration or the epochs for your training. Okay. So your iteration will stop if it hits this limit of 500. The network can run up to 500 passes over the training data. After that, it will automatically stop. Okay. So this is what again I have written the doc string within the function. Also you can see I am initializing my model, that is MLP is equals to MLP classifier. Hidden layer sizes is equals to hidden layer sizes from the input that you give. Activation function again from the input. Max iteration again from the input. Random state 42. Within that also you have to set verbose is equals to false. If you set verbose is equals to true, which is default also, you will keep on seeing all the iterations, how it is processing and all those things, which is unnecessary compute. So that's why we keep verbose is equals to false generally. Okay. Then MLP.fit, we always fit on train, X train and Y train. We'll do the prediction, Y pred, MLP.predict, X test. Accuracy is equals to accuracy score, Y test, comma, Y pred. I'm just taking accuracy. I'm not going into F1 or whatever. Just simple. And written what? Written MLP, accuracy and Y predicted value. This is what this function will do. Okay. Now if, yeah, question? This is a simple data set. That's why I took ReLU. But later you can see in configs, I have even used TANH in logistics also. Okay. And your activation function is, which were the activation functions? What you talked about, it was the solver. What is the activation function? ReLU, sigmoid, and TANH. And the solver is Adam, SGD, and LBFGS. So Adam is by default over here. If you will see, if I click on this, see, activation ReLU, solver Adam by default. Okay, yeah. So I'm changing my activation function. Configs in this, I'm experimenting. I'm not doing that hyperparameter tuning. I'm just directly using this in the config. Hidden layer, I'm overwriting it with 16 instead of 32. Activation, keeping ReLU. Hidden layer sizes. Now 32 comma 16. What does this mean? It means that I have two hidden layers. First hidden layer has a neurons of 32. Second has 16. Can you see that it is reducing? I'm not increasing it. Always we reduce as we move forward in the number of hidden layers. Activation again ReLU. Over here I am using three hidden layers. 64, 32, 16 are the number of neurons in that. Activation is ReLU. Again over here, this is 32, but the activation is TANH, and this is 32 activation logistic, that is nothing but sigmoid only. Then a empty list of results. For config in configs, all of this, it will give me model accuracy and PRIDS. If I will run this train and evaluate function on my config, that is hidden layers it will take and the activation it will take from here. So all this thing and it will append in this results. So let it just, yeah, done. I'll show you results also. Okay, all of that came. Now what is this? Let's go to the accuracy and just take that value. So I'm printing the model performance comparison where I'm taking the config and the accuracy, and this layer means print layers is equals to how many layers I was having in the hidden layer. What was that? What was the activation function and what is the accuracy? Take that and print it. This is the model performance. When I had just one layer with 16 neurons and activation ReLU, this was the performance. When this was two layers, this is the accuracy. All accuracy are nearby. But if you see over here, with single layer with 32 neurons, activation function logistic accuracy is the highest. Now, this is what math is happening behind that. We are not getting into that. What is the transformation and all is happening. But if you remember, I told you how many neurons you should take as a rule of thumb to start with. Num is equals to number of features or 2 times or something like that. If you remember, we have number of neurons as number of features as 30. So 32 is near to that. It is a simple data set with just 539 somewhere rows. So that's where one hidden layer is sufficient. Activation function is logistic. It is a binary classification problem. Generally, in that case, your logistic or sigmoid will work perfectly. And that's where we are seeing 97% approximately accuracy, right? I've just plotted all these accuracies together, all these loss curves together. What was the loss? That is the error. So you can see over here different ones. This blue color one, this is over here. So how many epochs? Till 500. This blue one has the line till 500. So this model, which is your best model, sorry, not best, which is the best one? 32 with logistic, purple one. This purple one went till 410 something, whereas this one, which is simple model with one activation function, 16 neurons only with ReLU, it went till 500 epochs. Many of them stopped before that also because they were not seeing any improvement. Max they can go is till 500, but they can stop before also if they are not having any improvement. Okay. So just this is a bar chart to show you how the performance is. You have already seen this. Logistic with one hidden layer and 32 neurons worked best, followed by TANH and followed by this one, the two layers with ReLU, and then was your single layer with ReLU. 3 layers with ReLU performed the least. Almost all are similar, but if you have to still choose which is the best, this top one is the best one. Okay, so forward propagation, input moves through weighted connections, activation applied, output generated. Backward propagation, error between predicted and true labels is calculated, then propagated backward to update the weights. That's what I told you. Different hidden layers and activation function change how the network learns pattern. Loss curves show how quickly, slowly model converge. Bar chart compares final accuracy for each model. Okay, so this is what I've written in the doc string just for the explanation's sake. So all the explanation and everything. This is a very simple notebook, but it is a beginner's notebook. You can start with this thing. You have the baseline code and you can play around with other hyperparameters also. Any question, guys? What other are there or okay, so if you where's my notebook? Yeah, if you go over here, just let it come up. Yeah, you can see so many yeah, so many other hyperparameters are there, like alpha is there, your batch size, learning rate, initial power, max iteration, so many things are there. Early stopping, it's set to false and all. What is beta? Generally, we don't touch all of this. The most of the things is hidden layer, your activation, solver, alpha, and your learning rate. That these are the things, and max iteration, of course. These are the things generally we touch. Now, what is alpha and learning rate? What is learning rate? Any idea? Forget about alpha. What is learning rate? As the name suggests, can anybody guess what is learning rate? Okay. Anyone else? Yeah, what it is learning. Your model is learning what and when it is learning. Yeah, we have the loss, right? You remember, guys, I told you during back propagation, it updates the weights, right? So, what is this? This is the learning that is happening. So, how big the steps it has to take when updating the weights during back propagation is known as learning rate. High learning rate, you are taking big jumps. Like if I am saying learning rate is zero point 0.1, it will update the weight whether increase or decrease by a variant of zero point 0.1. Whereas if I'm saying low learning rate, it would be small, careful steps, more accurate but slower. Like if I'm saying low learning rate as 0.0001, so it will update the weights increase or decrease in that step only. Okay, so that's what is the learning rate. You can play with that also for the don't keep it too small. Generally, I think so default is 0.001. You can try with 0.005, you can try with 0.0001, like that, with small tweaks over there. That is also one of the significant parameter, hyperparameter, that your neural network has. Now, what is alpha? Have you guys read about L1 and L2 penalties in your linear regression? It was, I think so, in your additional material. If not, go back and read it whenever you guys find time. This alpha is related to that only. It is the regularization strength to prevent overfitting. So it is again by keeping the weights small. Larger alpha value, you are giving stronger penalty, simpler model will come. A smaller alpha value, you are giving less penalty, more complex model will come. So this is directly related to your L1, L2. If you understand that, you would be able to understand alpha. So these are some of the important hyperparameters that we generally play around with. Any other question, guys? Yeah. Mm-hmm. 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 Okay. So it first of all, you can't say I'll talk in terms of the real life. What happens in industry? It's not that while seeing the data, I can tell you you have to build logistic regression or neural network or XGBoost or bagging or random. I can't tell you. Nobody can tell you. Okay, howsoever experienced that person is, nobody can tell you. They can just tell you, okay, this is classification, this is regression. You use classification models or you use regression model, that's it. But you can't take a decision based on the data which model you have to use. You have many parameters to consider before making that decision, and then also it's not a straightforward decision. If I'm working in a banking industry, which is a highly regulated industry, and my model output will impact the customers directly, will go out to the customer directly. As per the regulations, I can't use a black box model. That's very clear. So it means now I am limit, and let's say it is a classification problem. I am limited to only models which are white box in nature. White box means they would be explainable at the end. I can justify if I'm rejecting somebody's loan, I can justify on what parameters I am rejecting when they come back to me. Okay, so that's what is the white box model that you can explain, whereas black box models are the ones where explainability is the problem. 100% explainability is not there. You don't know what happened at the back end. You can't give a equation that due to this happened and all that blah blah blah. That won't happen. Okay, so what happens is, let's say if they are fine that I use a black box model, my first choice, if I am allowed to use a black box model, would be neural network. Why? Because this behaves like a human brain. It is complicated and it is proven to give a higher performance compared to any simpler machine learning algorithm. So if I'm giving a chance of logistic regression and neural network, and I can build a black box model, I will use neural network. That's one thing. Apart from that, it's still, I won't just go with neural network. I will build 5 to 6 different model. I will try XGBoost also. I'll try the random forest also. I'll try neural network also. I might try any other model also. I can try any. I have to try 5 to 6 models. Within that, I have to choose which few are better. Do their hyperparameter tuning. Okay, so this is an iterative process. So where to use it to answer your question? You can use it for any classification. The neural network that I am right now talking about, it is artificial neural network. You have different variants of that. You have RNN, you have a CNN. So like that, you have different variants of neural network for different case studies. But when you are having a simple classification or a regression problem, you can use the code that I have given you, that is in the collab just now I showed you, where you don't where your concentration is on a better performance. The neural network is go to model as your first choice, but I'm not saying that should be your only choice. You should try other models also and then decide which is better. So to answer in short, where to use it, there is no direct answer that where can I use it. I can use it on medical data, no. I can use it on engineering data or any bank data, no. Nobody can tell you. You can use it everywhere, wherever it is finding its place. Clear? Yes. Yes, like for a classification problem, you will build a logistic regression, decision tree, random forest, XGBoost, or anything. Similarly, you can build a neural network also. Okay? Yeah. Any other question, guys? No, no, you can work on collab. Just Google simple this collab. Simple, you just do this thing. Collab will open up whichever this. I'll give you the link also. It will directly open up that collab. And if you don't have a notebook, you can create your own code and work. Everything it is like the Word in Google. It is the Google Doc. So similarly, this is collab. You don't have to install anything. Most of the packages, the advanced packages or latest version packages are available with you over here in Collab. That's why it is used. Neural network. How? s- Yeah. So tell me one thing. Till how long you will do hyperparameter tuning in XGBoost? How much? What is your best? Can you define that? then how can you say that XGBoost has 30 parameters? Again, in 30 parameters, you can't even think of how many iterations will come, how many permutation combination will come to exhaust it completely, right? Right, same thing happens in neural network. You have so many different parameters. In XGBoost also, you will consider few important, in any model you will consider few important hyperparameters which you will play around with. In neural network also, you will use this only. Okay, first of all, your XGBoost works well on your tabular data banking and all this. Neural network also works that way. Whereas your XGBoost struggles on raw images, text data, audio data, and all that. For this, you need feature engineering and all. Neural network works on unstructured data, structured data, everywhere it works. Okay? So that's what I'm not saying that neural network will be better in every case. No, nobody can tell that. XGBoost could be better in a scenario. Neural network might not be able to perform. So that is also, no model is 100% best or 100% accurate. Yeah, yeah. That's what I told you. Neural network. If that would be the case, we had logistic regression. Why the need of decision trees, random forest, XGBoost, cat boost, boost, all this bagging and all came into picture? They're just improving the models. They're trying different maths behind that. Same way goes with neural network. Neural network is also it for complex data. Neural networks works better because it is thinking from the human perspective. And now, since generative AI is there, neural network is the base for that. We are building on top of that. We are not building on top of logistic regression, right? We are not building on top of XGBoost because they have a limitation. They can't work on the audio data, they can't work on the text data, they can't work on the unstructured data as good as your neural nets. Okay? Yeah. Okay, guys. So, we are done. I have shared the link in chat also for the Google Colab. Once I upload this recording, I'll share the link of the recording also. Please let me know if you have any questions later. We have the group. You guys can uh, keep your post your questions. Others will also learn through that. Apart from that, I've started with neural nets. Next time we are going to move to embeddings. These are all the building blocks of generative AI. Okay, and then we will get into this encoder model, decoder model, and then into how Gen AI works, Chat GPT, and all those things, and finally into agentic. So it is a long journey, but I have to build this base of neural nets. I will also cover concepts of NLP because that is also required for your generative AI, where what is token, what are semantics, and all those things. We need to learn those terminology to get into generative AI. I know very basics have been covered in generative AI in your courses, but that is without covering NLP or neural net, you won't understand what generative AI does, what its power is, and how prompt engineering is powerful. So that's where I thought of uh, starting from the base. In case you have any other topic in mind, and you want to learn something extra on this neural network, you want me to further expand on that, let me know. But I just wanted to touch the initial base of that so that we can go into generative AI. Okay?